Good morning. So we are starting the course on operating systems. So when we talk about operating systems, firstly we have to see what is meant by an operating system, what is the responsibility of an operating system, and what is the environment under which the operating system has to work. Okay. So firstly let us see that what is an operating system. So to answer this question of what is an operating system, we can say that operating system is just like a resource manager. Okay. Say for example, when we perform our day-to-day work, say somebody has rang you, you are attending a telephone call. In between, there is some other urgent work for which you have been interrupted. So what you have to do is, you have to decide that which one is more urgent, whether it is the telephone call that you are attending or it is the interruption which has been done while you are attending the telephone call. Okay. So based on that immediate decision, you have to decide that whether to continue with the telephone call or you have to interrupt the telephone call, ask the other party to wait for some time, ring you back again, and in between you can do the other task for which you have been interrupted. Okay. So here what you are doing is, you are basically managing the time. Okay, because during the same span of time, you have to do more than one task. Similarly, we can say that operating system is also a manager which manages the resources of the system. Okay. So when we say that it manages the resources of a computer system, first we have to know that what are the resources that are present in the computer system. Okay, and what is meant by management of all those resources. Okay, to see that what are the resources in an operating system, now resources in a computer system, the first resource in a computer is the central processing unit of the computer, or CPU. Okay, and you all know that this is the central processing unit of a computer which performs the execution of a program operation. Okay. So whenever the user writes the program, usually you write the program in high-level language. Okay. Then the program has to be compiled, and the compiled program or the executable program has to be executed by the CPU to give you the desired result. Okay. Now when the CPU executes a particular program, I hope all of you know that when you compile a program, the executable code is stored on the disk or hard disk of the computer. When you want to execute it, that executable code has to be brought from the hard disk to what is called a main memory in the computer system. Okay. And when the CPU executes the program must reside in the main memory. The CPU cannot directly access anything which resides on the secondary storage or hard disk, maybe magnetic tape or floppy drive or CD-ROM, whatever it is, all those are secondary storage devices. And CPU does not have any direct access on the secondary storage device. Right. So whenever a program is to be executed, the program must be brought from the secondary storage to the main memory so that it can be accessed by the CPU for execution. Not only the program, even the data which is to be processed has to be brought from secondary storage to main memory in order that the CPU can access the data. Okay. So anything which is to be accessed by the CPU must reside in the main memory. It cannot reside in any of the secondary storage. Okay. So the first and foremost resource in a computer system is the CPU. Okay. Now in the earlier systems like DOS-based computer system. Those were strictly single user or single programming system. In a DOS machine, it was not possible to execute more than one program at a time. Whereas, on the other hand, your Unix-based machines, you all know that Unix-based machines are used as servers, in the sense that more than one person can work on a Unix-based machine simultaneously. Okay. Now, when I say simultaneously, whether at the same time instant more than one user program can be executed or not, we'll come to that later. But as an user, when I work on a machine, it appears that the machine is giving me all the time. Though practically it does not happen so. It gives me only part of the entire duration of time. Okay. So, when we talk about managing this resource that is CPU, we have to think that if you have more than one user working on a machine simultaneously, in that case, how this CPU has to be shared among all those users. Okay. So that is one resource, that is the central processing unit, and the responsibility of the operating system is to manage this central processing unit. Okay. The second resource in a computer system is the memory, or to be more specific, it is the main memory. Okay. Again, as I said, that whenever a program or any piece of data is to be accessed by the CPU, that program as well as that piece of data must reside in the main memory, right? So, if we have a multi-user or a multi-programming system, okay, where we say that more than one user program is to be executed simultaneously, so obviously more than one user program or parts of more than one user programs as well as the corresponding data units on which the programs has to be executed, they also should reside in the main memory simultaneously. But in a computer system, we have a single memory block. When I say block, it does not mean that it's a single memory chip. There can be multiple memory chips to make a single memory block. Okay. So I have a single main memory block in the computer system which has to be shared by more than one user programs working on the computer system simultaneously. Okay. So again, the question of management comes because I have a single memory block which is to be shared by more than one users or user programs. So how to manage this sharing of a single memory block by more than one user programs? Okay. So that is again a responsibility of the operating system. Okay. Then the third category of resource that is present in a computer system is the secondary storage. This secondary storage consists of the hard disk that is present in the computer. It consists of the magnetic tape that is also present in some of the computers. It also consists of the floppy drive, the floppy disk. It also consists of your CD-ROM drive or the CD-ROM. All of them come under the category of secondary storage. Okay. Now, though the main memory as well as secondary storage, both of them are some kind of memory, but we put them under separate category because the way in which the main memory is accessed and the way in which the secondary memory is accessed, they are different. Not only that, in the secondary storage, when I have different types of secondary storage, I have hard disk, I can have floppy drive, I can have magnetic tape, I can have CD-ROM. The characteristics of all these secondary storage are also different. They don't have uniform characteristics. So accordingly, the way in which these different secondary storage devices are to be accessed, they are also different. Okay. So main memory, which is accessed directly by the CPU, and we have said that the secondary storage cannot be accessed directly by the CPU. So whenever the CPU finds that it needs a piece of program to be executed next, or it needs a piece of data which is to be processed next, okay, if it finds that the required instruction or the required program or the required data, they are not present in the main memory, it has to instruct another unit, which usually we call as device driver. It has to instruct the device driver that such and such data units or such and such program units are not present in the main memory, which is required. So now it will be the responsibility of the device driver to look for that piece of information, it may be instructions or it may be data, from the device or the secondary storage device and pass it to the main memory so that it can be accessed by the CPU. Okay. So find that the way the main memory is accessed directly by the CPU and the way the secondary storage is accessed, they are different. So when we discuss about the memory management, though both of them comes under the category of memory, we will discuss them separately. Main memory will be one type of access mechanism. Secondary storage will have some other kind of access mechanism. Okay. So in addition to these resources, that is CPU, main memory, secondary storage, we also have another very fundamental kind of resource in a computer system, which are called input-output devices. Or in short, they are popularly known as I/O device. So what are these input-output devices? These are the devices through which an user will feed his data, an user will write a program. That is, anything to be inputted to the computer system, the device which is used for that is an input device. Okay. So typically or normally what you use when you work on a computer, that is a keyboard. Through a keyboard, you either feed the data or you write an instruction, you give some command. Okay. So all these things are done through the keyboard. So keyboard is an input device, right? Similarly, when you want to get something from the computer, you get it in the printed form. For that, what you use is a printer. So printer is an output device. Similarly, if you want to have some visual outputs online, you make use of the video terminal. So video terminal is also an output device. Okay. Now, considering the nature of these input-output operations, you find that this secondary storage can also be considered as input-output device. Okay. Because usually what you do is, whenever a data file is to be processed, the data is normally residing on the secondary storage. When you execute the program, some instructions within the program, they open the data file, read the data from that file, and after the reading is complete, it closes the file. That means it is also inputting the data, but in this case, not through the keyboard, but it is inputting the data from the secondary storage or hard disk. So in that sense, hard disk is also an input device, right? Similarly, when you process a data, how often we make use of the printer? Very rare. When we just want the final printout to be included in some report, we make use of the printer. But otherwise, what we normally do is, all the outputs that we get, we usually store it on the secondary storage in the form of a file. that is a processed data file or output data file. Okay. So considering that, the secondary storage or the hard disk can also be considered as an output device, right? So when we talk about this I/O devices, along with that, this secondary storage will also be considered. We'll consider the secondary storage as some special kind of input-output devices. Okay. So usually, these are the four kinds of resources which are present in a computer system. One is CPU, then you have the main memory, then you have secondary storage as a special kind of input-output device. We have other normal input-output devices like keyboards, video terminal, printer, these things. Okay. So the responsibility of the operating system will be to manage all these resources in an efficient manner so that more than one users, in computer terminology, you can say that more than one clients, they can make use of these resources simultaneously to get their work done in as efficient as possible manner. Okay. So the major responsibility of the operating system will be to manage these resources. Now, whenever we talk about all these resources are confined in a single system. But you also have to think whether the modern operating system can be satisfied, can remain satisfied with a single computer system in isolation or not. Because as you know, that with the advancement of computer networking, with the advancement of information distribution, we cannot remain satisfied with a single computer. Okay? So now we have to think of that if I have multiple computers which may be distributed in different geographical locations. Okay? But what I have is a network interconnecting all these computers which are distributed in different geographical places. Right? So I have different isolated computer systems. Each of those computer systems are full-fledged computer. I mean, they are independent computers. So each of them will have all these four kinds of resources. So even if the network fails, the computer can work in isolation. Okay. So I have these different independent computers and a network interconnecting all these computers so that you can transfer the information from one computer to another computer, from that to somewhere else. Okay. So really we have to think of a distributed environment where the information, required information, can be distributed in different places. Okay. So I have to think of a distributed computing system. Right? So when I talk about this distributed computing system, we have isolated computers consisting of, let us put in the form of a block diagram, so